All right, this lesson is about conjugate numbers, specifically the conjugate of complex numbers such as these, and how we can use them to simplify the quotient of two complex numbers and ultimately write them in standard form, a plus bi. All right, when you write the conjugate of a complex number, the real part stays the same. You just change the imaginary part to the opposite of whatever it is. So the conjugate of negative 7 plus 4i would be negative 7 minus 4i. And the conjugate of 8 minus 5i would be 8 plus 5i. Conjugates are useful because they have the following special property. Well, let me show you. So if I write a complex number like 8 plus 5i and its conjugate, which would be 8 plus 5i, if we multiply these together, watch what happens. All right, so of course I'm going to distribute the 8. So 8 times 8 is 64, and then 8 times 8 times 5 is 40, so that's going to be 40i. Okay, and then if I distribute the negative 5i, that's going to give me negative 40i, and I'm going to get negative 25i squared. So if you look at the like terms in the middle here, anytime you have conjugates, because of the way you have the same numbers, only opposite, then these terms are always going to cancel out because they make 0. All right, so those i's are going to go away. I'm going to bring down my 64. Now, you know that this I squared is negative 1. So really we have negative 25 times negative 1. So that makes a positive 25. Now the main thing to notice here is, notice that all of the i's are going away. And I'm going to be left with just a real number. In this case, 89. All right, so the key property of complex conjugates is if you multiply a complex number by its conjugate, you're going to get a real number. No I, no imaginary. All right, that's going to be useful because if you want to rewrite a quotient of two complex numbers in standard form, a plus bi, you're going to have to get rid of the imaginary number in the denominator. You're going to have to make it a real number. And what better way to make it a real number than to multiply by the conjugate? Again, focus on the denominator. It's all about the denominator. So of course the conjugate here is going to be 1 plus 3i. Now we're going to have to multiply by the same thing in the numerator so we can avoid changing anything. Anything divided by itself is 1, so we're really multiplying by 1, so it's okay. But in the denominator, when we do our double distributive property, all right, so we're going to multiply the 1 by everything. All right, so that's going to give me 1, and then 1 times 3i is 3i. Okay, and then we're also going to distribute the negative 3i times everything. Okay, so negative 3i times 1 is going to be negative 3i, and negative 3i times 3i is going to be negative 9i squared. Okay, we're going to do the same thing here. Okay, so I'm going to distribute the 3. So 3 times 1 is 3. 3 times 3i is going to be 9i. Okay, then we're going to distribute the 2i, so 2i times 1 is 2i. And 2i times 3i is going to be 6i squared. Yeah. All right, so let's just simplify this down. So combining like terms and remembering that I squared is -1. All right, let's see what that does. So combining these like terms right here. So I've got 3 plus 11i, and then this is going to become -6. And then down here, of course, these are going to cancel out, all right, just like we planned. So I'm going to have 1, and this -1 is going to change this to +9. Okay. So in the denominator now I have 10. Combining the 3 with the -6, that's going to give me -3, and then plus 11i. Now, we're going to write this in standard form a plus bi, so we need to separate this. So what we're going to do is we'll take the denominator and write it under each part of the numerator. So if I split this up, this is going to be -3 over 10 plus 11 over 10i. Always watch out to see if there's anything that can be reduced. Neither of these fractions can be reduced. So that's going to be the answer. Whoa. All right, so again, we will take the denominator and multiply it by the conjugate, which is going to be 5 minus 3i. We have to multiply the numerator by the same thing. So we will also do 5 minus 3i. So notice we do not do the conjugate of the numerator, just the denominator. These have to be the same. And then we will double distribute. You know, some teachers call this foiling. I never have. So I'm going to multiply this 5 times everything. So 5 times 5 is 25. And then 5 times -3i is -15i. Okay, now I'm multiplying the 3i times everything. 3i times 5 is +15i, and 3i times -3i is -9i squared. Okay, in the numerator, I'm going to distribute the 4. So 4 times 5 is 20, and 4 times -3i is -12i. Then I will distribute the 2i. So 2i, -2i times 5 is -10i. -2i times -3i is +6i squared. Okay, these are going to cancel out, so I just have the 25. This I squared is -1, and this I squared is -1. So that's going to change this to a +9. And up here, I've got the 20, -12, and -10 is -22. So that's -22i. And this -1 is going to make this a -6. Okay, let's see. So 25 plus 10 would be 35. So this must be 34. And then 20 minus 6 is 14. So 14 minus 22i. Now, we're shooting for standard form a plus bi, so we need to separate this into 2 separate fractions. So I have 14 over 34 minus, because of that minus, and then 22 over 34i. Now, I'm noticing that these are both even, so I definitely want to reduce. All right, so dividing both of these by 2 is going to give me 7 over 17. All right, and dividing both of these by 2 is going to give me 11 over 17. All right, so make sure you reduce your fractions into lowest terms. Okay, for number 4, once again, we will multiply by the conjugate. So this will be 2 plus 3i. And you have to do the same thing in the numerator. So another 2 plus 3i. And now it is time to double distribute, or FOIL. Okay, so 2 times 2 is 4. 2 times 3i is 6i. All right, now I distribute the negative 3i. Negative 3i times 2 is negative 6i. Negative 3i times negative 3i is negative 9i squared. All right, meanwhile in the numerator, I distribute the 1. So 1 times 2 is 2. 1 times 3i is 3i. And then I distribute the I. Okay, so I times 2 is 2i. And I times 3i is 3i squared. I squared is negative 1. The 6i and the negative 6i are going to cancel each other out. So here I have 4, just bring down this 4. Negative 9 times negative 1, that's going to change to a positive 9. Over here I'm going to have 2 plus 3i plus 2i is 5i. This negative 1 is going to change this to a minus 3. Okay, in the denominator, I'm going to have 13. And then 2 minus 3, that's negative 1. So negative 1 plus 5i. And we will just separate this into 2 separate fractions. So that's going to be negative 1 over 13 plus 5 over 13i. It's a plus bi. All right, let's do one more. All right, again, focus on the denominator and multiply by the conjugate. So 4 plus 5i, the conjugate is 4 minus 5i. And we'll have to do the same thing in the numerator. Okay, so now let us double distribute. So I'm going to multiply the 4 by both of these. All right, so 4 times 4 is 16, and 4 times negative 5i is negative 20i. All right, so now I will distribute the 5i. So 5i times 4 is positive 20i. And 5i times negative 5i is negative 25i squared. All right, now I will distribute the 6. So 6 times 4 is 24. 6 times negative 5 is negative 30i. Okay, so now I will distribute the 4i, the negative 4i. So negative 4 times 4 is negative 16i. And negative 4i times negative 5i is positive 20i squared. Okay. Now, remember that I squared is negative 1. In the denominator, these will cancel each other out. So I just have 16. And then a negative times negative is a positive, so this will be plus 25. Over here I've got my 24. Let's see, negative 30 and negative 16 together make negative 46. So that'll be negative 46i. 20 times negative 1 is negative 20. Okay, so in the denominator, I'm going to have 41. Now 24 minus 20 is 4, so I'm going to have 4 combining these, and that just leaves my negative 46i. Alright, now we just need to separate this into two different fractions. So that's going to give me 40 over 41 minus 46 over 41i. Alright, always check to see if these will reduce at all, but 41 is a prime number, so it cannot be reduced. And that's it.